Now, okay, there's a little bit more I want to talk about before we head out, right? A little bit more. Let's talk about some of those invisible beam types of light. I don't have as much to say about them. Let's talk about the invisible light, okay? Check it out. The very first type of invisible light was discovered totally by accident. And it was discovered totally by accident in a science class that was describing this. That science class had this kind of setup about 200 years ago, and they were explaining how refraction worked. Of course, they didn't have a flashlight, it would have been a candle, but they had this piece of glass and they were making a rainbow. And so that particular teacher taught them about refraction, and then the class left to go home. And this scientist had to take all of his equipment and put it away, okay? And when he did that, he made an accidental discovery because he had this set up. He had a candle right here, splitting the light into a rainbow, and he had a thermometer from a different experiment, okay? And so he was waving that thermometer around, and most of the time, the thermometer read room temperature, okay? The thermometer read room temperature. But don't overthink this. If he took the thermometer and he put it in the rainbow, what would happen to the temperature on the thermometer? If he took it and put it in this rainbow, what would happen to the temperature on the thermometer if it absorbs that light? Yeah, it would go up. It would go up. The same thing that would happen if he put it in this beam of light right here, right? So in other words, if he has the thermometer right here, it shows, like right here, literally right here, it would be room temperature. But if he puts it here, it would be hot. Back here, room temperature. Back here, hot. Room temperature, room temperature, room temperature, room temperature, hot. Okay? Room temperature. Now, here we go. Then he put the thermometer right here. Right here. Should it be room temperature or hot right here? It's not in the rainbow. Should it be room temperature or hot? Right here, it's room temperature. Right here, it's room temperature. What about right here? It should be room temperature. But if he put it right here, it still got hot. This place right here was still hot, okay? Now check this out. What is going on? What is going on? What happens is that if it's still getting hot right here, that means it must still be absorbing light. And that means that there must be more light in this beam of light than we can see. Because what that's saying is that some of it came through the glass and ended up right here. There's invisible light right here that we can't see. Now, let's see if we can figure out something about it, okay? Let's see if we can figure out something about it. If it bent to here, did it bend more or less than this visible light did? If the invisible light is ending up right here, did it bend more or less than this visible light did? If it came through like this and ended up right here, it bent less. So, according to what we know about refraction that we were just saying, is it a longer wavelength than visible or a shorter wavelength than visible? If it bends less, is it longer than visible or shorter than visible? So longer or shorter? Remember, red bends the least of the visible, and we said it's the longest of the visible. So if this is bending even less, that's right, it's even longer. So the type of light that ends up bending to here is longer than visible light. Now, here we go. Let's use our 3 L's. Let's use our 3 L's. This new invisible light that's longer than visible. Would it have a higher or lower frequency than visible? If it's longer than visible, would it have a higher or lower frequency than visible? Use your 3 L's. It's longer, so it's going to have lower. Same with energy. This invisible light that is longer than visible light is a lower energy and a lower frequency. And that's where it gets its name. Its name comes from being lower energy than red light. The name for this type of light is infrared, which is frequently shortened to IR. Infrared. So infrared light, infra means under, and so this name comes from its energy level being under the level for red light. It's a lower energy than visible light is. And its wavelength range is anything between 700 nanometers all the way up to 1 millimeter. And 1 millimeter doesn't sound very big, but it's much, 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 much bigger than 700 nanometers because nanometers are so small. Okay, now, somebody's pointing something out. Someone has asked, how does it produce more heat if it has less energy? And the answer is it doesn't, okay? This ties into what I want to ask here. Is there any way for the human body to detect infrared light? Because we can't see it with our eyes. I'll go ahead and tell you there is. What part of our body can detect infrared light? What part of our body, let me put it in another way, can feel infrared light? What part of our body detects infrared? It's our skin, right? Our skin can, in a way, see infrared, okay? So this kind of is going to answer your question about heat. So infrared is not itself heat, but things that are hot give off light, okay? And one of the types of light that hot things can give off is infrared. And inside of our skin, we have little detectors just built in everywhere that can pick up infrared light. And so if something is hot, it's going to give off infrared light, and that's what you feel as heat. But it's not that the infrared is heat. It's what we feel as heat, okay? But think about this. Is something that's giving off, or if something is very, very hot, it's not going to just give off infrared, right? Like, so imagine this. Imagine you go to like some hot pavement in like a hot parking lot one day, okay? Let's say you go to a hot parking lot, and you go to touch the ground, okay? You go to touch the ground. It's gonna feel hot, right? Is it going to kill you? That's a question there. Is the heat of the pavement probably going to kill you? It's not going to kill you, right? But if you make something very hot, like a fire is much hotter than the pavement in a parking lot, right? A fire is very hot. And it's so hot that it's not just giving off infrared, it is also giving off a lot of visible light. That's the glow you can see. So something that is even hotter will give off not just infrared, but visible also. It needs to be even hotter to give off a lot of the higher energy visible light. And a fire can hurt you very quickly, right? So basically, the hotter something gets, the higher the energy of light it can give off easily, right? So yes, infrared is just the part that we can feel when something is hot. But it's not the only kind of light it's giving off. It's just the one we have a detector for. So like you were saying, yes. Okay? So basically, you that were asking that question, you're absolutely right with your second assessment there. Infrared is just the part we see, or sorry, that we feel. So longer wavelengths, less energy. Shorter wavelengths, more energy.